devices. So here we have an IPv6. Okay, welcome back to CCNA Troubleshooting Lab number 3. If you are recreating this on Eine's rack rental equipment, please make sure that you load the OSPF working configs on all of your devices. If this is the first lab you're starting with, load it on all of your devices, and then load Troubleshooting Lab number 3 on all the devices. So here we have an IPv6 problem. R2 cannot IPv6 ping the loopback 0 of R3. Let's verify that that is indeed a problem. Ping 2222.0.1.0.0.0. It said loopback 0. Yes, loopback 0. So that is BB 0B : 3. Doesn't work. And even tells us a little bit of information about why it didn't work. No valid route for this destination. So that gives us a starting point for our troubleshooting. No changes to the physical layer are allowed, so that means we can't bring up interfaces or bring down any interfaces. Can't change any access lists, but we can change individual ACEs. Access group commands cannot be modified or removed. And we must ensure that the finished working lab adheres to the original lab specifications. Okay, so we don't have any OSPF, we don't have any route period, OSPF, static route, or otherwise. So we know that there is supposed to be an OSPF neighbor relationship between router 2 and at least one router, if not more. So I think if we do show IPv6 OSPF neighbor, we do see some neighbors. So this is good. And they are in the full state. Okay? So let's just start jumping to each one of these neighbors and see. So looking at our topology diagram, I would try to, if this isn't a real live production environment, I would want to get this thing up as quickly as humanly possible. So now that I know that router 2 has an OSPF relationship with router 4, I would start looking at that. And we know that he's got that relationship, so I jump right to router 4 because ultimately we're trying to reach this network right here via IPv6. So let's go to the router that's closest to that and see if he has an entry. So router 4, let's go into router 4's routing table. Okay, show IPv6 route OSPF. He's got a few of them. We're looking for the BB0B, and he does not have it. I don't see BB0B. So let's see if he has an OSPF v3 relationship with router 3. Okay, it looks like he does. Oh no, that's switch 3. That's switch 3. So out of my serial here, I should have a couple of neighbor relationships, but I don't. Clearly there's a problem with my neighbor relationship with router 1, and I assume this would be my IPv6 neighbor relationship with router 3, but that's not working. Okay, so let's check. Is that interface actually configured to be included in OSPF? Show IPv6 OSPF interface brief. Yes, it is. Make sure it's in the right area because the areas have to match between the routers. Okay, so that's not the problem. Let's see if there are any access lists on that interface that might prevent OSPF from dialoguing back and forth. And since we're talking about IPv6, we would be looking for the IPv6 traffic-filter command. And I don't see any IPv6 traffic filters. But I do see, actually I don't see one thing in here that should be here. We know that OSPF version 3 forms neighbor relationships using link local addresses. And with frame relay, you have to be able, on a non-broadcast multi-access network, like network H, you have to be able to map the DELSI number to the layer 3 address you're trying to reach. Well, I see some frame relay maps here to reach the global address of my neighbors, but I don't see any frame relay maps indicating how to get to the link local address of my neighbor. That's definitely going to cause a problem. Okay, so let's go over to router 3 and discover what his link local address is so we can add it in here. All right, here is his link local address. Let's copy that. Go back to router 4, interface serial 1/0, and add a frame relay map. And to reach that, he would take DELSI 341. Okay. Show run interface serial 1/0. So remember that network H, so let's just do this, show IPv6 OSPF interface serial 1/0. This is considered as, where is it? Non-broadcast. So because it's non-broadcast, that means the only way you're going to form an OSPF relationship across that kind of an interface is to have OSPF neighbor statements. Well, we did. We did have our OSPF neighbor statements, but what we were missing was Frame Relay was saying, how do I get to that neighbor? I have no idea what DELSI number to use to reach these link local addresses. So I had to add in a Frame Relay map to reach that DELSI. While I'm here, let's go ahead and add in a second Frame Relay map just to reach router 1 as well. I've already got his link local here, so I'll just trust that that is the correct number. And to reach that router, we would go across DELSI number 141. Okay. Show IPv6 OSPF neighbor. Okay, well, I just brought up the neighbor to router 1. That's good. Still don't have a neighbor, though, getting to router 3. So let's see what's going on with router 3. Show IPv6 OSPF interface brief. Check to see if OSPF knows that it's supposed to be active on that correct interface. And it is, so there it is. That's network H. It is in the correct area. Okay, that's good. Show run interface serial 000.134. Once again, checking to see if there's anything that would be preventing the OSPF communication, like access lists or something weird like that. And it looks like we have the same problem here. We don't have a frame relay map pointing to the return address of our link local neighbor. Okay, so I'm not sure which one is which, so we're going to have to find that out. Find out which one is which. So let's go back to R4 and figure out what his link local address is. Show IPv6 interface serial 1/0. All right, so it's this one, 7AE0. Frame-relay map IPv6. Put in the link local address of my neighbor and the DELSI used to reach that neighbor. And then let's put in the other frame relay map. And there we go. Neighbor 4444 just came up. And while we're here, let's put in the other one. 78E0, so this must be the link local address for router 1, which is across Delcy 131. All right, great. So let's go back to router 4. And now see if he has an OSPF v3, an IPv6 route to this network. This is the one we were trying to ping that was not working. So the BB0B. And he does. There it is. Now let's see if he has communicated that to router 2. And he has. So now let's just see if router 2 can ping it. And he can. So in this particular lab, the problem was that we were missing some IPv6 frame relay maps. Looks like we also had some problems on the point-to-point link. Let's check that out. Going back to router 3, show IPv6 OSPF neighbor. Okay, so we see serial 000.134, but what we're missing is this connection right here. There's no neighbor relationship across the point-to-point frame relay cloud. So let's see if we can figure out what's going on there. So router 3, show IPv6 OSPF interface brief. Okay, he is configured to run OSPF across that interface, so that's good. It is in area 1. All right. Show run interface, and let's take a look at that interface, see if there's any IPv6 traffic filters or anything. No IPv6 traffic filters. But before we leave this router, there is a problem. This. It's not supposed to be Delcy 133. It's supposed to be Delcy 132. Another way, if let's say we just hadn't seen that, we hadn't spotted it, and we had done all of our OSPF troubleshooting. So if we had done all the layer 3 and figured out, okay, OSPF is fine, there's nothing wrong at layer 3, and then we started moving down to layer 2 and started troubleshooting frame relay, well then our next logical step would have been to do the show frame-relay PVC command to troubleshoot that. And that's when we should have noticed, wait a second, Delcy 133 deleted? Deleted means I'm using a Delcy that the WAN switch doesn't recognize. I'm telling the WAN switch about a Delcy that doesn't belong to me. So at that point I would have needed to look at my actual topology diagram, and I would have realized, oh, wait a second, these guys are supposed to be communicating across Delcy 132, not 133. And then when I went back to look at my interface, that's when I would have seen this. So let's go ahead and change that and make it the correct Delcy. Okay, let's shut it down temporarily. Put in Delcy 132, no shut. And there we go, look at that. Within just a couple of seconds, my OSPF neighbor relationship came up on that interface. Now we're supposed to adhere to the original design of the lab. So right now, what have we verified? What have we fixed? We have confirmed that there is now an OSPF relationship between router 3 and router 4 across the frame relay. We've confirmed there's an OSPF relationship between router 3 and router 1 across the frame relay. That's good so far. What else do we need to confirm? Well, I don't remember checking to see if there was an OSPF relationship between router 3 and router 1 across network H, and I didn't check to see if there was a relationship between 4 and 1 across the PPP cloud. So I need to check that as well. I need to check those red connections to see if our OSPF v3 relationships exist there as well. Okay, so let's see here. Show IPv6 OSPF neighbor. So across this, I should see 2 neighbor relationships, and I do. So my connection between 3 and 1 is fine. He actually has 2 connections between router 3 and router 1, and that's good. Everything looks great. So the last thing to check is the connection between router 1 and router 4. So let's check that. Let's go back to router 4. Show IPv6 OSPF neighbor. And that looks good. Well, this is across the frame. Let's see here. Serial 10. Yeah, I'm missing one here. So I should have another OSPF relationship across serial 1/3. And I don't even see serial 1/3 in this list. Show IPv6 OSPF interface brief. Okay, OSPF is configured to run on that interface. It's in area 1. Okay, so once again, let's check the interface from the running config, see if there's anything in there that would prevent that from happening. Aha, the old shutdown command. And there we go. The OSPF process comes up. And now I should have all of the neighbors I needed to see, and I do. So there were several problems in this. Missing IPv6 frame relay maps, a serial interface was down, and we had an incorrect DELSI assignment on our point-to-point frame relay circuit. Okay, so in this section, we're going to be going into CCNA Troubleshooting Lab number 4. Like the previous labs, please make sure that you load your OSPF working config on all devices and then load the Troubleshooting Lab config on all devices. So in this particular lab, our problem is that R2 cannot telnet to R3. If R2 is using loopback 0 as a source and trying to telnet to R3's loopback 2. Okay, so if you recall from back when we built the main monster lab, as I like to call it, when that was built, R2 was allowed to use this as a source and telnet to this as a destination. And now we're saying that is not working. So first of all, let's check it out and make sure that it's not working. Okay, so there we're telnetting to 3331. That's the loopback 2 of router 3 with a source interface of loopback 0 on router 2. And we get this address, this message, destination unreachable. Okay, starting at layer 3 again, which is my preference. See if we have a route to that destination. And we do. Okay. Next, our route was learned from 9.25 on Fast Ethernet 01. That is router 4. So let's see if router 4 has a route to that destination. And he does. Now he has a static route pointing at 9.34. That is the correct next hop. That is router 3. Okay, so at this point we know that, looking at our diagram here, if router 2 initiates a telnet, his routing table says go to router 4. And then router 4 will go directly, due to his static route, to router 3. So we know that, that being the case, router 2 is going to use a source IP address of 9.27 in that telnet. So in order to respond to that telnet, router 3 has to have a route back to this network right here. Router 3 has to know about this network. So let's see if router 3 has a route to that, to the 9.24 network. Show IP route 190.190.9.24. That is subnet F. And he does. He does have a route. Okay, so now that we have routes there and back, we know it's not an IP routing problem because we have IP route connectivity all the way to the destination and all the way back. So the next thing I would check is, okay, well, we were testing this with Telnet. Is there any other kind of protocol that works? Well, let's test ping, right? Ping is one of our favorite end-to-end testing methods. So let's go back to router 2 and ping 3331. Can he ping it? Yes. Ah, wait a second. Wait a second. In our lab, router 2 is using loopback 0 as a source. He was using loopback 0 as a source. So what I need to do is I need to make sure that router 3 has a return path to this network. Okay, so let's check that out. So that's the 198.0 network. Show IP route 190.198.1. Okay, so he does have a route. And can he ping it? Yes, he can ping it. So we do have end-to-end IP connectivity. At least ICMP can get there all the way and back, but Telnet cannot get all the way and back. In my mind, the first thing that would come to my mind would be access lists. Maybe there's some sort of an access list or something blocking it somewhere. Okay, so the access list would not be on router 2 itself. And the reason for that is because even if there were an access list somewhere on router 2, let's say on some of these outbound interfaces right here, it would have no effect. Because an access list, an outbound access list, only works for packets passing through a router. When the router itself is generating the packets, like in this case, if router 2 is generating the telnet himself, his CPU ignores any outbound access list. So we don't even have to bother checking router 2 because any outbound access list there will not prevent this in the first place. Okay, so we know those packets are going to go here to router 4. So let's check to see if there's any access lists on Fast Ethernet 01 or this interface right here, because this is the egress interface that router 4 uses to reach that network. So let's see if there's any ACLs on router 4. Show run interface fast 0/1. Okay, I don't see any access list blocking traffic coming from router 2. Show run interface serial 1/0. Okay, we do have an outbound access list. Okay, so now we need, I should say we have an outbound access group. So now we need to take a look at that access list and see if this could be the culprit. It might not be, but let's check it out. Show IP access-lists. And here is 101. So remember, this is being applied in the outbound direction from serial 1/0. Okay, so let's take a look at this. This would permit TCP from a source of 3331. Well, we can stop right there because outbound on serial 1/0 will not have a source of 3331. That would not be the source of any packet going out that interface. Deny TCP from the host 3331. Once again, this is an outbound access list. So placed right here, going in this direction. So there's not going to be any packets going in that direction with a source address of 3331. That's not going to happen. Permit TCP from 190.190.00.0015.255. All right, so now we got to pause for a second and say, all right, will that actually match packets that are sourced from right here? Because that's the source of our packets. Will it match those? 190.198.0. So let's take a look. So we have 190.198.1. That's going to be the source address of those packets. So the question is, will this match that? Well, the 190.190 certainly will. That's matching. And in the third octet, .15 says, make sure that the first 4 bits of the third octet are 0000. And that is true. Of the number 8, the first 4 bits would be 0000. So this does match. Okay? And then it says EQ telnet. Well, wait a second. If router 2 is initiating the telnet port number will be in the destination of that TCP header. It won't be in the source. So this is actually not going to match. Even though it says permit, it's not actually going to match that packet because this is in the wrong place. If it was going to match that packet, this would have to be over here in the destination field. Okay, so that's not going to match. So then let's go on to the next one. Deny, okay, so here we see a deny TCP, exact same source, so we know it's going to match router 2, going to the host, and that's it. So this is denying all TCP from router 2's loopback A, subnet A, going to the host of 3331. It actually says 2 matches. So this is our problem. Sequence number 40 in access list 101 is blocking that telnet. Now let's go back to our restrictions. The restrictions said no existing access lists may be deleted, but individual ACEs may be deleted or changed. All right. So if we just deleted that, if we deleted sequence number 40, that should work. Because sequence 10, 20, and 30 are not matching on the packets. 50 will permit anything, so let's just delete sequence number 40. No 40. Okay, let's review that access list again. That sequence number is gone. So let's go back to R2 and try our telnet. And it works. There we go. So that is successful. So in this particular lab, problem was that R4 had an access list, and one of the entries in that access list was blocking the telnet session. And so what we ended up doing was deleting that individual ACE entry that was dropping the traffic. Welcome to CCNA Troubleshooting Lab number 5. If you haven't already done so, please load the OSPF working configs on all devices, and then proceed to load the Troubleshooting Lab number 5 configs on all devices. So in this particular lab, we once again have an IPv6 pinging problem where router 2 cannot ping the loopback 0 of router 3. So if we bring up our topology diagram just real quickly, problem here being that router 2 is a source, cannot ping BB0B on router 3. So let's verify that ping is not working. Ping 2222.1100.0 BB0B::3. Okay, so the ping does not work. It tells us there's no valid route for the destination. Show IPv6 route OSPF. We're looking for BB0B, and looks like most of our routes are actually gone. This is all we have. Okay, so starting out with, do we have an OSPF neighborship with OSPF v3? Show IPv6 OSPF neighbor. And yes, he has all the expected neighbors that we would hope to see across the two sub-interfaces, neighboring with router 3, and across, he's got a neighborship with switch 2. Now what I don't see here is any kind of OSPF neighbor relationship with router 4. So just to show us what we have right here so far, router 2 has an OSPF relationship. He's got 2 of them with switch 3, and he's got 1 of them with switch 2. But he doesn't have one with router 4. If switch 3 and or switch 2 have relationships with router 4, that won't be an issue. Let's see if switch 3 and switch 2 have, actually let's just go right to router 4 and check to see the relationships he has. That way, instead of going to 2 separate devices, we can just check it on 1. Show IPv6 OSPF neighbor. All right, so he has an OSPF neighbor relationship with switch 3. Okay, so we don't see, so this is what we have so far. We have neighbor relationship here, and we have a neighbor relationship here. So if router 4 actually knew about this route, he should have sent it to switch 3, and switch 3 should have flooded it to us. Now it is a problem. We do have a couple of additional problems here. Switch 2 should have a relationship with 4, and router 2 should have a relationship with 4. So that's a problem. But that wouldn't necessarily prevent us from getting where we need to go if 2 to switch 3 to router 4 was functional. So let's check that out. Let's see, does router 4 know about this route right here, like he's supposed to? Let's go on to router 4 and check him out. Show IPv6 route OSPF. We're looking for BB0B. And he does not. Okay, so that's why he hasn't advertised it to anybody else, because he doesn't know about it. Show IPv6 OSPF neighbor. Okay, so we have some OSPF neighbor problems here. Across network H, which is our frame relay cloud, he's supposed to have 2 neighbors, and those are clearly not working. Also, across his point-to-point connection, serial 1/3, we're supposed to have a neighbor relationship with router 1. Don't even see that at all. Okay, so we can troubleshoot a variety of things here. Let's see what's going on with the frame relay cloud. So first of all, show IPv6 OSPF interface brief. Okay, OSPF knows it's supposed to be on the point-to-point connection, the PPP. It knows it's supposed to be on the frame relay. They are in the correct area. Here's the connection it has to switch 3. Okay, well this explains why we don't have an OSPF relationship between router 4 and anybody else on subnet F. Right here. So here's router 4. OSPF is not included in this list. This interface is not in OSPF, so that's why he did not form an OSPF relationship with switch 2 or router 2, because we don't see fast Ethernet 0/1 in this list here. Like I said though, not necessarily a deal breaker. Probably something we want to troubleshoot, but right now we just want to see why he doesn't have any kind of connectivity to router 3. Okay, so let's just start with the non-broadcast cloud. Show run interface serial 1/0. Okay, the interface is shut down. Is there anything in our restrictions that would prevent us from bringing that up? No changes to the physical layer topology are allowed. Okay, so we can't change the physical layer topology. So that means that this whole subnet is off limits. This interface is down. And since we're not allowed to bring it up, that subnet is off limits. So that means then that the only way router 4 could get to router 3 is via the PPP connection. And we don't know what the status is of these two interfaces yet, but it can only go across this. Okay, let's check the serial 1/3, the PPP connection between these two routers. So we already saw that he knows that frame relay should be operational. Okay, let's go over to router 1 and make sure that on the other side of that PPP connection, he also knows that frame relay should be operational on that interface. Show IPv6 OSPF interface brief. Okay, he knows that OSPF should be operational on there. It is in the correct area. All right, let's take a look at our running config and see if there's anything on that interface that could potentially cause OSPF to break. All right, so at this point it might be easier for us to line things up side by side. So let's line up router 4 and router 1. Okay, so show run interface serial 1/3. And here we go. Okay, so let's check some basic things. The interface is not shut down, so that's good. Is it in the correct subnet and mask? Yes, 957, 958. The mask is the same. Encapsulation's PPP, okay. It's using the exact same OSPF authentication type, same password. From an IPv6 perspective, it's in the same subnet, although that's not really necessary. And OSPF area 1, okay. And it looks like router 1 is going to challenge router 4. And if you did the Monster Lab, you remember that is intentional. Router 4 is acting as the customer, and when it calls up router 1, it gets challenged. So from a configuration standpoint, at least on the interface, everything looks okay. All right, let's now move down to, let's see, is there anything else at layer 3? I don't see any access lists here that would block anything. So from a layer 3 perspective, I think we've exhausted all of our options. There's nothing that's misconfigured at the networking layer. So let's move down the OSI stack down to layer 2. So it looks like from the standpoint here that on the interface at least, our layer 2 configuration is correct. Let's see if PPP is operational like it should be. So we'll use the show interface command for that. Let's do it again. Here's a problem. Physically, it's up. At layer 2, it's down. And we see at LCP, he's sending requests. But if everything was up at layer 2, we would see a whole bunch of open messages like LCP is open, IPCP is open, IPv6 CP is open. So clearly there's something going on here at layer 2 with PPP. All right, so let's investigate this a little bit further. So I don't see any LCP configuration options that are not supported. In other words, what I mean by that is there's no interface level command that I can see where one side would be demanding something of PPP that the other side absolutely does not support. For example, if one side said, I can only do CHAP, and the other side said, I can only do PAP, that could be a cause for why PPP wouldn't sync up and wouldn't be operational. But there's nothing like that in here. One side's doing CHAP, the other side isn't configured for anything, so he will say, okay, I can do CHAP. So let's check and see if CHAP is correctly configured here. So on serial 1/3 on router 1 is going to be the challenger. And he's going to get a chat message from customer. Okay, so let's check and see if our username and password is correct. Section username. Okay, so we've got username customer and customer match up. Password INE. Okay, that looks good. What about router 4's perspective? When router 4 receives a challenge from ISP, he also has to have some sort of way of responding to that. Well, we don't see anything here in the interface. There's nothing in the interface that tells him what he should use as a password. So the only other place it could be would be a username command. So show run section username. And here we see username INE. No, that's not it. Username ISP. Well, wait a second. We've got a couple of mismatches here. First of all, the ISP in this case is all lowercase. Here, it's all uppercase. And here, the password, when he's talking to customer, he's going to use a capital INE. And here, it's a lowercase INE. So it looks like we've got a mismatch between our username and our password statements. So let's go ahead and fix that. If you remember building this lab, R1 is configured correctly. The username and the password are supposed to be in caps. So let's go ahead and fix this here on router 4. So we will take out this one that's wrong. Okay, now we'll put it back in with the correct password. Okay, but let's see here. We also see that the CHAP hostname is lowercase ISP. Let's see if that makes a difference. Let's see if that makes a difference. I definitely know 100% that the password is case sensitive. If it's capital on one side, it's got to be capital on the other side. Something in the back of my mind, though, tells me that the username doesn't necessarily have to be case sensitive, but let's find out. So here, if we match this up, okay, so now he's going to say, I am ISP. He says, oh, ISP, okay, then I'll use a capital INE. And he says, oh, customer, capital INE. Okay, so let's see if that made a difference. Show interface serial 1/3. Now the line protocol is up. LCP is open, and our network control protocols are open. Yeah, so this confirms what I had mentioned earlier, that in the username statement, the username does not have to match in case. It does not, it's not case sensitive, but the password is case sensitive. Okay, so that being the case now, let's look in router 4. Previously, router 4 was missing BB0B. As a matter of fact, he was missing all this stuff. All this stuff was gone. But specifically, let's look for BB0B in router 4's routing table. Show IPv6 route OSPF. And there it is. There is BB0B. So now let's go back to router 2. And our original problem was router 2 could not ping the loopback 0 of R3. Can we ping it now? Yes, we can. So here is the solution to troubleshooting lab number 5. We saw that the serial 1/0 on R4 was disabled, which was the physical connection leading us into the frame relay cloud. But according to our restrictions, we were not allowed to change anything at the physical layer, so that prevented us from bringing this up. So we pretty much had to learn all of our routes across the PPP connection between R4 and R1. But we saw that was down at layer 2, and this ended up resulting because of mismatched username and password statements. On one side, the username was in the password was in lowercase. On the other side, the password was in uppercase. And although the case of the username is not important, it is case sensitive when it comes to the password. Both passwords have to match in every way. So that concludes lab number 5. Welcome to CCNA Troubleshooting Lab number 6. If you haven't already done so, please load the OS